So this here says a solution was prepared by dissolving 24.40 potassium chloride KCl in 25 grams of water. Calculate the mass percentage of KCl. So let's do A first. This is A, right? So this is a 4-part question. So it says here, what is the mass percent? Mass percent of KCl. So it's asking what is the mass percent of KCl. So when we talk about mass percent, what we're doing is we're taking the percentage or the ratio of the solvent and the solute. So it says here, so I can say that the mass percent of KCl equals, it would be a mass, obviously, the mass of KCl divided by total mass, right? So this would be total mass would mean KCl and water, right? And then times 100%, right? That's our definition of our mass percent. So I'm gonna give you a moment to think about this question as well. And what you're gonna do is, if you're in the chat, again, wave hi, maybe say hello. And what we're gonna do is we are going to answer this question together. So again, mass percent of potassium chloride in the solution, right? And we're saying the solution is the water, right? The water is our solution here. So in 225 grams of water, right? So in order for us to solve this, what we can do is we have the mass percent, which is what we're solving for. So this would equal mass of potassium chloride. We know it's in grams, right? So in grams, we have it's 24.0. So we don't have to do much math here. 24.0 KCl. And so we're going to divide that by the total mass, right? The total mass would be the mass of the total solution, right? So the total KCl and water, right? So this would be 225 grams of water plus 24, right? Plus 24.0 grams, right? And this would multiply by 100%. So this give me 24 grams over, this is 225 plus 24 would be 249 grams, I believe, times 100%. And then what I can do is I can simply just plug in my calculator, right? So 24 grams divided by 249 times 100 would give me a value of 9.64. 9.6. I have 3 decimal places, so this is 9.64% here. I'm doing 3 significant digits, right? 9.64% would be my mass of KCl. They did the exact same thing, mass percent equals mass of KCl to total mass times 100, which is good. And then they did the exact same math here. You get 9.63, 9.64. That's correct. Sweet. So let's look at B here. 2B. It says calculate the mole fraction of the ionic species. So we're talking about mole fraction of KCl in solution, right? In solution. So what do we mean by when we talk about mole fraction? So take a moment to think about this problem as well. What is a mole fraction? So if you look at the if you think about it in terms of what the word means, so we have mole. So we're working in moles, and then it's a fraction. So it's going to be a proportion or ratio of KCl in total solution. Right? So we're comparing moles of KCl and total moles, right? So that's what we're doing. So it's basically the same thing as mass percent, except what we're doing is we are, instead of using the mass, we're using the moles, right? So again, I can say that mole fraction would equal the moles of KCl divided by total moles, right? Total moles in solution, right? It would be a percent, so we would multiply that by 100%, right? Actually, no, it's not a percent, sorry, it's just a fraction, so we don't actually have to multiply that by 100%, sorry. It's just a fraction here, right? And that's going to equal, so let's see, we have our moles of KCl. How do we solve for moles of KCl? We have to do moles equals mass over molar mass, right? So this would be mass of KCl divided by molar mass of KCl. This is all divided by total moles of solution, right? So this would be mass of KCl divided by molar mass of KCl plus, I need the mass of water, and I need divided by the molar mass of water, right? So again, this here is a big formula, but it's not really that confusing, right? And this here is, let me just read, this here is This here is NKCl, so the moles of potassium chloride. This here is also the moles of KCl, and this is the moles of H2O, right? So that's what all we're doing here. We're taking the moles of KCl and we're dividing it by the total moles in solution, right? So in solution means that it's going to be both the moles of potassium chloride and the water here. So that's what we're doing here. So let's plug this all into our calculator. Sorry, I did this in blue, right? So let's do that. Whoops. Siri randomly goes off. I don't know why. So this is massive potassium chloride. We have 24.0 divided by what's the molar mass of potassium chloride? Well, we can look at our periodic table here. Right? Our potassium here is 39.09. So 39.0. I think it's 09 or 0. I'll say 0.10, 0.98. Let's take all the decimal. 0.98 plus our chloride, which is chlorine here, is 35.45, right? Plus 35.45 grams per mole. So that's going to be divided all by the same thing. So massive, so this is 24 again. 24.0 divided by 39.098 plus 35.45. And then I'm going to add that by the moles of water, right? The moles of water and the mass of water, which is 225 grams. And we divide it by the molar mass of water. So if, again, H2O here is water, right? I know that oxygen here is 16 grams per mole, and 2 hydrogens means 2 times 1 grams per mole, right? As you can see here, hydrogen has a molar mass of 1, and oxygen has a molar mass of 16, right? So I have 16 plus 2 hydrogens, which is 2, is 18, right? So this would be 18 grams per mole. So now what we can do is we can plug this all into our calculator and get the mole fraction here. Let's calculate that. So we have 24 divided by 39.098 plus 38.45. Yeah, it's 38.45, right? Oh, 35.45. My writing is really bad. 35.45. This would give me a mole fraction of 0.319. Would be our numerator, 0.319. 3219, sorry. 3219. 3219. This would be moles now. And this would be, again, 0.3219 moles plus our moles of water, which is 225 divided by 18, which will give us 12.5 moles. And then this equation now becomes really nice, right? So again, I have here 0.3219 divided by, this is 0.3219 plus 12.5. I'm going to get a value of 12.8219. And then we just have to divide the two numbers, right? 0.3219 divided by 12.8219 would give me a value of 0.0251 would be my mole fraction for this question here. So again, what I did here was, it kind of looks complicated, but it really isn't. Again, it's just the moles of potassium chloride divided by the total moles in solution, right? So I found the moles of potassium chloride. I don't know why. Tchaikovsky, nice. Moles of potassium chloride here divided by the moles of potassium chloride and moles of water, right? So this is the total moles in solution would be the denominator here, and the numerator here is the moles of potassium chloride, and then I just did, it's basically just math, right? Again, I know what moles equals mass over molar mass, right? So mass over molar mass divided by mass over molar mass plus mass over molar mass, right? And then again, I know these two here are the same, right? These two here are potassium, moles of potassium chloride. So I know it's 0.329 here and 0.329 here. And to solve for the moles here, I have, again, it's just mass over molar mass. So grams, so mass of water divided by the molar mass of water to give us 12.5. And then I simply divided the two numbers out to get 0.251. So that's kind of our mole fraction for this question here. Let's see what they did here. And they did the same thing. Mole fraction equals moles of KCl over total moles. That's good. Mass over molar mass gives you 3.217. I got 39. Close enough here. And then water is 225. Yeah, that's good. It was 12.48. I got 12.5. And they divided by the total here to get 0.251. And that's the exact same thing, 0.251. Sweet. So that's B. That's a long question. And then 2C would be calculate the molarity of KCl, right? So it says here, calculate the molarity of KCl if total volume of solution is 239 milliliters, right? Okay, so that's what it's saying. Molarity of KCl if total volume of solution is 239 milliliters. So maybe take a moment to think about this, and then we will take it up together. So again, what is molarity in the first place? What is the what is molarity? And we know molarity here is by concentration, right? We learned about concentration in grade 11 chemistry here in the Ontario curriculum, right? So we know that C here, where concentration equals moles over volume, right? N over V, right? And this here again, this is concentration equals moles over volume, right? And moles are MOL, and here is in liters, right? To get capital M, right, as our molarity, right? So that's kind of our concentration here. So to calculate the molarity of KCl in the solution if the total volume of a solution is 239 milliliters, right? Well, what we can do is we already have the moles of KCl already. We solve for it here, right? We know moles of KCl is 0.329, right? So what I can do is I can just simply say that this here is 0.3219. And this is moles of KCl, and we're dividing it by the total volume of solution is 239 milliliters, right? So the total volume is 239 milliliters, but we have to convert milliliters into liters, right? 200, and I'll do some blue, so that's because it's side work here. So we want it to be the SI unit for concentration, or our concentration is moles per liters, right? And we're given our volume in milliliters, so we have to convert this into liters, right? So in order for us to do that, we have to divide by 1,000, right? So again, I have 1 liter equals 1,000 milliliters, right? And these two are going to cancel out, which means I'm dividing, right? So 239 milliliters divided by 1,000 would give me 0.239 liters. So we plug into 0.239 liters in this case, and we get the molarity of potassium chloride, which is 0.329 divided by 0.239. 0.3219, sorry, divided by 0.239, you get a molarity of I'm doing this in 3 decimal places, or 3 significant digits, so 1.35 molarity is my final answer here. And let's check our work here. It says molarity is moles over solute over liters of solution. It should be here total solution, but I guess I'll forgive that. 0.321937, almost the same. 0.239 liters, good. 1.34, 1.35, awesome. So that was a C, which is great. And let's do D now. Almost done one problem. It's a long problem here. It's 2D. It's asking us the molality of KCl in the solution. So we talk about this concept of molality. What is the concept of molality? We know that molality, or this is a small m, but not to be confused with mass. So I'm just going to write it out. Molality equals, we have the moles, obviously, because the word mole is a molality here. I'll do that in blue. We know that the word mole is a molality, right? So that's fine. So we know it's the moles of KCl, because that's what I need, right? Moles of KCl divided by, I'll put this into black, divided by, we have kilograms. This is in a different unit, kilograms, or the mass, kilograms of solvent, right? Or in this case, what our solvent here is water, right? So we have this here is kg of water here in this case. So in order for us to solve that, we actually have, again, we have all these components here already, right? We have our moles of KCl. We've already used that. This is 0.3219 KCl, mole KCl. And we're dividing it simply by the mass of our, or in kilograms of our solvent, right? So we have here, we have 225 grams of water, and we have to convert that to kilograms. So in order for us to do that, let me do that in red here as side work. So we have 225 grams, and we have to change that to, to kilograms, right? So in order for us to do that, we have to divide by 1,000, right? So I would say this is 1 kilogram equals, there's 1 kilo, there's 1,000 grams in a kilogram, right? So we're dividing by 1,000, which would give us 0.225 kg. So 0.225 kilograms of water, which will give us our final answer, and I'll write this in blue, which is 0.3219 divided by 0.3219 divided by 0.225. It will give us an answer of 1.43 will be our final answer for our molality of potassium chloride in solution. So 1.43 would be our molality for our solution here. And this is in moles per kilogram. Moles per kilogram here. 1.43 moles per kilogram. So again, same thing here. 0.3217 divided by 0.225. And again, you got 1.43 moles per kilogram, or M here, if you want to use the units here. And so this is here, great solution, perfect solution and analysis here. So that's awesome. So that was question 2, by the way. That's one question.